All right, so I had project 6, and the first question was compute the derivative of g of x equal to x plus 5 to the x power. So first I'm going to take the derivative of x plus 5 raised to the x, and it's going to equal to e to the x natural log of x plus 5. And I did this by applying the exponential rule of a to the b equals eb natural log of a. And then next I'm going to do the chain rule, but first I'm going to separate the equation. So I did f equal to e to the u and u equal to x natural log of x plus 5. So like I said, the chain rule is going to be used, and it's going to be d over du, e raised to the u power, d over dx, and then in parentheses x natural log of x plus 5. I'm just going to write out what I'm doing, so I said apply the chain rule right here. Alright, so I'm going to zoom out real quick just to show you everything, and we're going to get back into the math problem. And so we're going to find the derivative of e to the u, which is just going to equal e to the u. And then we're going to find the derivative of natural log of x plus 5 times x. And you're going to apply the product rule for this one. So it's going to be d dx times x natural log of x plus 5 plus d over dx natural log x plus 5 times x. And like I said before, I'm just going to write out apply the product rule just so we don't get confused along the way. Alright, here's another zoom out just so you can see everything that's happening again. And then we're going to try to find the derivative of those things even further. So I'm going to do d over dx times x, and then the derivative of x is just going to equal to 1. And then we're going to try to find the derivative of the natural log of x plus 5, and that's going to end up equaling 1 over x plus 5. And then for those who are confused about how I solved it, I'm going to show an arrow down here just to quickly write out the problem. So just like before, we're going to apply the chain rule, but this time I'm going to let f equal, sorry, I'm going to change the color real quick to green, just so it's easier to see. I'm going to let f equal natural log of u, and u equal x plus 5. And just again, I'm just going to apply apply the chain rule right there for you. Alright, and then we're going to try to find the derivative of those things separately. So write d over du, natural log of u, which is just going to end up equaling 1 over u. And then we're going to try to find d over dx, and then x plus 5, which is just going to end up equaling 1. And then we put those two together, and it's going to be 1 over u times 1, which is then going to equal 1 over x plus 5 times 1, which is simplified version is just 1 over x plus 5. And then for those of you who are confused, I'm going to put up here, substitute u back in for the problem. Alright, I'm just going to zoom out again just so you can see what I've done so far, just so it's easier to follow along. And then next we're going to add what is solved together. I'm just going to write it out just so that it's not so confusing when I zoom back out again for the final answer, just so it's easier to follow along. And then that's just going to be 1 times the natural log of x plus 5 plus 1 over x plus 5 times x, which in simplified versions is going to be natural log of x plus 5 plus x over x plus 5. Now that's just the first half of the problem solved. We still have to figure out what e to the u is going to equal and substitute all that back in. So next I'm going to write add e to the u back into the problem. Again, I'm just writing it out so they can see what I was talking about in case it's hard to understand me over this voiceover. Alright, just going to zoom out one more time just so you can see everything that's going on. So we're going to let e to the u times, and then what we said above, it's going to be the natural log of x plus 5 plus, plus x over x plus 5 Alright, so then we're going to figure out what e to the u is, so we're just going to plug in what we know, so it's just going to be e raised to the x natural log of x plus 5 times that by what we saw before, which is going to be the natural log of x plus 5 plus x over 5 Alright, and then we're going to solve that even further. So I'm just going to draw a little arrow real quick. And I'm going to change the color back to green just so it stands out a little bit more. So it's going to be e x natural log of x plus 5, which above I said would also equal x plus 5 raised to the x, which is what we was given in the original problem. And then in case you guys were confused, I'm just going to put up here, substitute u in for the e to the u. Alright, so then we basically have our final answer when we put everything together after we substituted e to the u to x plus 5 raised to the x. And that final answer is going to be the natural log of x plus 5 plus x over x plus 5 times x plus 5 raised to the x. Alright, so that's just the final product. That's how I saw the answer. It's just a little quick overview. I'm going to highlight the final answer and the original question just so that everyone can see how I got there and what the answer was. Now the second question I had was a true or false one. I said the integral of x to the 7th power, 7 to the x power d of x is equal to x to the 8th power over 8 plus 7 to the x plus 1 over x plus 1 plus c. Now in order to solve this, I started to take the first half of the equation. So I did x to the 7th power, and then what I got for that was x to the 8 over 8. I'm going to draw a little arrow real quick. And then I'm going to change the color to green just to show you my work. So I did x to the 7th power is equal to x to the a plus 1 over a plus 1. And then I just filled in the a spots for the next step. So I filled that in with 7. So I did x to the 7 plus 1 over 7 plus 1. And then the simplified version is basically what I just said, x to the 8th power over 8. And then I got that original problem above by applying the power rule. I'll write that in real quick, just so that you know what's going on. Alright, and then just an overlook of the problem that I just did for a couple of seconds. And then we're going to do the next step, which is 7 to the x power. And for that answer, I got 7 to the x over the natural log of 7. And then again, I'm going to draw another arrow just to show you my work. I'm going to change the color to green again. Am I right? 7 to the x power is equal to a to the x over the natural log of a. And then that would equal the answer I said above, which would be 7 to the x power over the natural log of 7. And then I just got this from chapter 6, theorem 6.4.3. I'm going to write that in real quick. Theorem 6.4.3. Alright, just another overlook of the problem. And then I'm going to go down here, change the color to pink. And then I'm going to write therefore the integral of x to the 7th power, 7 to the x power, d of x is equal to x to the 8th over 8 plus 7 to the x power over the natural log of 7 plus c. Alright, and then I'm just going to take a quick highlighter and just highlight the answer. It's going to be false.